Hello, Professor Alan. This is the video explaining the code we used for the homework and the QTSPIM, homework. Sorry, the MIPS homework. QTSPIM is just a simulator. I'm going to go kind of fast because I already recorded this video several times and I'm kind of tired. Uh, Sorry for the noises in the background. I'm in my parents' house and it's noisy here, so let's go. So we have first of all our data section. We have all the ASCII messages we need for this program. It's a simple program. It's just showing some specific routines. A lot of code is kind of repeated. For example, the code for loading messages and print it to the inputs to the output, and some moving routines and jump. So let's go real fast. We have our main menu. The main menu is just asking the user for a number. So first of all, it's moving number 4. That is the service call for printing a message. We move it to B0 and A0, the register for the message, and we do the system call here to print the message in 8.0. So it's going to be print. We have here the service call to read a input from the general input stream. So we store in B0 the message, and we store it in a temporal number 4 to make sure the value is not lost when we use B0 again. We do the calling to subroutines. We have the first one is for comparing, second for adding, the third is for to subtract, the number 4 is for multiplying, 5 for division, 6 for knowing if a number is even or not even. We lost count. It's number 7, I think, is for looping. This is going from 0 to 1, and this is going. The last one is number 9 is for looping again using a 4, that is going to 0. And the end of our main menu, we print our final message, and we use the number 10 for exit system call. So the first thing that is going to execute is going to print the message pedir. It is going to be this string right here that asks the user for input a number. After that, it's going to jump to compare to 5. It's simple, but it's just for explanation purposes. The compare to 5 is going to load in temporal number 1, number 5 to compare, and it's going to compare right here. It's going to branch if the input of the user is less than number 5 right here in the temporal number 1. It means the number is less than 5, so it's going to jump to this label right here that just prints the number is less than 5. If not, it's just loading the message to print that is more than 5. And here in both cases we jump back to RE, that is return address. So if you go to the return address, it's going to be here, and after that we go to subroutine or adding. The subroutine to add is just printing a message indicating that it's adding, and is going to store in temporal number 2 the input of the user 2 times added. So for example, if user inputs number 3, it's going to store in temporal number 2 3 plus 3, and load service call to print a integer number. We move it to A0 and print the number. Again, jumping back to main menu, to the return address, we're going to restart, let's say in Spanish, just for explanation purposes. here in subtracting, we have printing the message indicating that is the subtracting subroutine, and we use the sub to store in temporal number 3 the input of the user 2 times. So if the user inputs 1, it's going to store in temporal number 3 1 minus 1. Always is going to all the times show a 0 because we are subtracting the input 2 times to the input of itself, but we can modify it to make it more complicated and show different stuff. But again, just for explanation purposes, we do simple subroutines because otherwise the video is going to be so long. We move the result to A0 because it's the special register to print the messages and integers and anything we want to show to the output. And the service call again is to print the integer. So we do the system call and it's printing the subtraction. Again, we go to the return address. Now we go to multiplying. Multiplying is showing the message that indicates there is a multiplying, and uses the MUL of mult to store in temporal number 4, the result of multiplying the input of the user by itself. So if user inputs 5, it's going to store in temporal number 4, 5 by 5, it means 25. We use the service call to print the result and do the system call and return to the return address again. After multiplying, we have division, and division is going to show the message. We have this validation to make sure that the input of the user is not a 0, otherwise it's going to show a math error and make the program fall. So if the input of the user is going to show any message here, it doesn't matter. It's just for validation and go back to the main menu. And if the input of the user is not a 0, it's going to store. This means moving from LO. LO is the register, special register where the result of the directive div store the results. So if user inputs 5, of course it's a division. Any number divided by itself is going to always give 1, so the result is always 1, but again, it's just for explanation purposes, so the code is simple. And again, we move the number 1 because we want to print in the integer. We move the result stored in temporal number 5 to A0, a special register for the output, and do the system call, and we jump back in both cases. If the input is 0 or if it's not. We go back to the main menu. After division, we print if the number is even or not even. We store in temporal number 6 a number 2. Why? Because to know if number is even, we need to divide it by 2 and load to the residual value. So we do the division here, and this time, as we want to know the residual, we, instead of checking LO as in division, we check high, because it's where the residual value stores instead of the result of the division itself. So if the residual is equal to 0, this special directive means branch equal to 0. If it's 0, it means the number is even. So we go here and print the message. If it's not, it means it's not even. So we print a message to make the user know the number is not even. Again, we in both cases jump back to the return address, to the main menu, and we go to the loop. this loop shows the numbers from the input to 1. So we print the measures indicating that it's just a loop cycle. We create the counter in temporal number 8, so we move the input of the user to temporal number 8. So let's say the user inputs a 5. So if the temporal is already 0, you're comparing here to 0, it means that it already ends. And before printing a 0, we jump to the end, so it's going to finish in 1. So we load the service call number 1 to print an integer number, and we print the current value of the counter. So we print, for example, first time is going to be a 5. We print a jump line, and we subtract 1 to the temporal counter. So instead of 5, it's going to be 4. And the second time we print it here is going to be 4. This cycle is repeated from the input to as long as the temporal is a 0, we go back. So making sure we jump before printing is how we print everything until 1 instead of 0. We jump back to at the end we jump back to the main menu, and the main menu last sub-process is going to be a 4 in Pascal-like. It doesn't really matter, it says Pascal, but at the end in assembler everything looks pretty similar. It doesn't matter the high level language. And the 4 is printing the message indicating that it's a 4. Again, we have a counter, and this time we print before, sorry, we're going to pause real quick. It was a noise, my father coming into the motorcycle. So we compare here, and if it's equal to 0, we jump to the end to add the 4. If not, we again load the number and do the system call into the jump line, and again is decreasing the counter by one by one until 0 this time. The difference why this goes to 0 instead of 1 is because of the difference of this directive. We have branch less than 0, and we jump here as soon as it reaches 0. So if at the moment it is equal to 0, it's going to jump instead of when it's less. And at the end we jump back to the main menu, and at the main menu, as I said at the beginning, we have the bye-bye message and the system call to end the program, and that's it. And to see this code being executed in the QTSPIM simulator, what we need to do is to go to File, we load the code here, and we have the left panel to see the values stored in any register at the moment. We have our section data. Everything looks really different because of the way QTSPIM works. The name of the messages are replaced by directions, so do not freak out if you see them different. And we have our text section again. The labels are replaced and everything. So do not freak out if anything looks really different. If you want to make sure where you are stopping and what that any line means, you can set by using right click a breakpoint, but we are not doing that for this sample. It's just for debugging reasons. We execute it. Let's use number 7, and we see that 7 is bigger than 5. 7 by 7 is 14. 7 minus 7 is 0. 7 by 7 is 49, and 7 divided by 7 is 1. The number is not even, and we have all the numbers from 7 to 1, and here we have all the numbers from 7 to 0. I'm going to execute it again. I'm going to close QTSPIM because I have a bug. That means that unless I close the program, it's not going to work again. This time I'm going to execute it using an even number. Let's see, 8. Again, it says it's big. No, I'm using an even, but less than 5 to make sure that it's working properly. All these routines. So I'm executing less than 5. Let's use 4 as an even number, and it says the number is less or equal than 5. 4 plus 4 is 8, plus 4 minus 4 is 0, 4 by 4 is 16, 4 divided into 4 is 1, the number is even, and the number from 4 to 1, and the number from 4 to 0, and that's it. That's all the explanation. I hope the audio is not messed up and everything is understandable.